transaction between Jack and Bill. The transaction between Jack and Bill. And understand how it operates. In the Bitcoin network, every user possesses two keys, a public key and a private key, which we spoke about, or which our session was based upon last week. The public key serves as an address known to everyone in the network. You can take it as an email address. And then on the other hand, the private key is a unique address known only to the user, similar to a password for your email address. Bill begins the transaction by passing the number of Bitcoins he wants to send to Jack, along with their unique wallet addresses, through a hashing algorithm, or technical terms. This information forms part of the transaction details, which are encrypted using encryption algorithms and Bill's private key. This process digitally signs the transaction, verifying its origin from Bill. The encrypted output is then transmitted worldwide using Jack's public key. And consequently, the message or transaction can only be decrypted by Jack's private key, which only Jack possesses as it stands. I'll leave the intricacies of the whole delving deep into cryptocurrency hashing algorithms, and then just to focus on blockchain. Now, these transactions, alongside many others, occur globally. So in this case, it's no longer just a group of 4 friends. It becomes like a global village, put it that way. So these transactions, alongside many others, occur globally. And they are validated and added to the blockchain block by block. Individuals responsible for validating these blocks are known as miners. They keep on mining Bitcoins, like we term it. What they do is to add a block to the blockchain, miners must solve a complex mathematical operation or a problem. The miner who solves it first adds the block to the blockchain and receives a reward in the form of Bitcoins. Now, these problems, we can't solve them as humans. It takes quite a large amount of power by the computer to solve them. And yeah, like I said, the miner who solves it first adds the block to the blockchain and receives a reward in the form of Bitcoins. The process of solving these complex mathematical problems is referred to as proof of work. It's kind of like you are showing a proof that you've done a work, and so we would have to reward you with Bitcoin, right? And the act of adding a block to the blockchain is called the mining, hence we call them miners. And as a result, after this mining has happened, as a result, Bill's and Jack's wallets, alongside with those of other network participants who have completed transactions, are updated accordingly. So depending on the number of Bitcoins that have been mined, and then that Bill or Jack or Ted or Sam or anyone globally has already, his or her account is going to be updated according to the number of Bitcoins that have been allocated to them. And that's just the whole bit of blockchain. It's quite very easy. It doesn't, well, when you go deeper into it, that's when it's quite tough to understand. But with this presentation, I believe it gives a clear picture of how the blockchain works. It's not that complicated, honestly. And you can see that it's very, very secured. Yeah. Thank you very much. And I'm open to questions from here. So it feels like I've been speaking for quite a long time. At this point, I would like to hear what you guys have to say and your questions. I'm open to questions too. Yeah.
Yo, Pascal, I have a question. I wanted to inquire that apart from the crypto space, what are the other use cases of blockchain?
Does anyone have a question? If there are no questions, it means I'm at liberty to also ask a question.
Like,
Just
I'm
to
asking
show
a
that
question.
you understand what
Pascal.
I said. I've said a lot, but I need to know that you understand what I said. Anyone?
Hello, Pascal.
Okay. Collins.
Can you hear me?
Collins is lost. Daniel. Hello, Daniel.
Pascal.
Yeah, Daniel.
Yeah, so there's a question from Collins there.
Okay.
Did you get to hear the question?
No, I didn't hear him. Sorry.
Yeah, so he's asking if there are any other applications of blockchain aside from the crypto space.
If there are other applications of blockchain aside
crypto.
Aside
from cryptocurrencies and transactions, like if it can be applied in other fields.
Oh, okay, I get you. A minute. So, is this still on the call?
Yeah. I'm still around.
Okay. So I think I believe that you can liken application of blockchain to the fintech space, but then the very known one is the one that is applied to crypto. That's the main one that's the main application for blockchain.
Oh, okay, nice.
Pascal.
Yeah.
Yeah, I also wanted to add that, like, I think it can also be applied to something like elections, like where we make sure that everyone's votes is located, it's being registered in the blockchain. Like, so we can all have like public record of who someone voted for. So that means that like there'll be much more transparency in the process and less corruption if we to do something like that.
Okay. Right. Any more questions? Okay. If there are no more questions, I don't know, Daniel, will it be okay to end the meeting, or you have something you want to add?
No, there's nothing to add. I think if there's no questions or contribution from anyone, we can end the meeting.
Collins?